Hello everyone, welcome to Think Like a Software Engineer Episode 3. One of the key skills that a software engineer needs is the ability to identify patterns. Often, coding problems are pretty complex and it can be difficult to wrap one's head around, but sometimes, if you can find a pattern within the complexity, you can simplify the problem to the point where it's easily solvable. Let's see how this works in action. So the other day, my friend interviewed for a software engineering position at Google and was asked the following question. Imagine a two-player game in which there is a pile of coins, and each player alternates turns, and on each turn, a player removes coins from the pile. However, on each turn, the player has the option to remove either just one or two coins. They always have to remove at least one coin, and they can remove two max. They cannot move 3 coins or 4 coins, etc. The key rule, though, is whoever removes the final coin loses. So, the exercise is to write code that determines, based on the number of coins in a pile, whether the player whose turn it is will win or lose. So, for example, if there's 2,756 coins in the pile and it's your turn, will you win or lose? Obviously, that version of the game might take a while, but that's beside the point. Will you win or lose if you're dealt 2,756 coins and it's your turn? Now, at first glance, this exercise appears overwhelming. It seems that we'd have to track every single possibility, every permutation of who picks what. And for a pile of 2,756 coins, there would be at least thousands of possibilities of different sets of moves. If you're familiar with the technique of recursion, that may make this process a little easier, but it's still quite tricky. However, let's see if we can identify a pattern in this situation. Now, here is the key trick for finding patterns that works in many situations. Look at the simplest version of the problem and work incrementally upwards from there. Let me show you what I mean. What is the simplest case in this game? The simplest case is where there is just one coin left in the pile. So let's start with this case and analyze it. If it is a particular player's turn, let's say it's my turn, and there's only one coin left, will I win or lose? Well, I am forced to remove at least one coin. I have to take that final coin, so I will lose the game. So let's write this down somewhere. We're going to write 1 equals lose. That means that on a given player's turn, if there is one coin left, that player will lose. Let's move on to the next simplest case, and that would be where there are 2 coins remaining. If a player is confronted with 2 coins, will they win or lose? Well, they will lose if they take both coins, but they have options. They could just take one coin, and that is what they'll do. They will leave the other player with being forced to take the last remaining coin. I will take one coin, the opponent will be left with one coin, and the opponent will lose. So, if I'm confronted with 2 coins, I will win because I will definitely take one coin away and force my opponent to take the final coin. So let's write this down as well. 2 equals win. That means a player confronted by 2 coins will definitely win. As long as they make the smart choice, of course, of taking away just one coin. Let's take the next case, that of 3 coins. Now, if I take just one coin away, I will leave my opponent with 2 coins, which we just identified would be a winning situation for the opponent. So I would lose. But I can and will take away 2 coins, leaving my opponent to be forced with a situation of 1 coin, meaning they will lose and I will win. So 3 is a winning situation for whichever player is dealt with that. Let's write that down. 3 equals win. Moving on to the next case of 4, this is an interesting case because if I take away 1 coin, I will leave my opponent with 3, which we just wrote down a second ago would be a winning situation for that player. So they would win, I would lose. Now if I take away 2 coins, I will leave my opponent with 2 coins, which is also a winning situation for the opponent. So either way, no matter which option I choose, I would give my opponent a winning situation, which means that right now I'm in a losing situation. So let's write this down, Whoever is dealt 4 coins on their turn loses. Moving on to case 5. If there are 5 coins left, if I take away 1 coin, I will leave my opponent to deal with a situation of 4 coins, which we just said is a losing situation for that player. So they would lose, I would win. Now it's interesting to note, at this point in the analysis, do we need to remember why someone loses when it's 4 coins on their turn? We actually do not have to remember that. We already did that logical analysis and we wrote down our conclusions. We have it down right here. We wrote down whoever has 4 on their turn loses, period. We don't have to get back into that analysis. We've already covered that. We just know that it's true. So, in our situation, when there's 5 coins left, I know that I can take away 1, leave my opponent with a situation of 4, which is a losing proposition for them, and that means I would win. So 5 is win. Whoever has 5 on their turn wins. In a case of 6, I have the choice of taking away 2 coins to also leave my opponent in the dust with a losing situation of 4. So 6 is also a win. With 7, though, if I take away 1, I give my opponent a winning situation of 6. If I take away 2, I give my opponent a winning situation of 5. So no matter what I do, 7 is a losing proposition. So let's record that as well. Whoever ends up with 7 on their turn loses. Let's just run through a few more cases. With 8, I can take away 1 to leave my opponent in the dust with 7. So 8 equals win. With 9, I can take away 2 coins to also leave them in the dust with 7. So 9 equals win. But with 10, if I take away 1, I give my opponent a winning hand of 9. And if I take away 2, I give them a winning hand of 8. So a player dealt with 10 coins loses. At this point, do we see a pattern? It would seem so, because every third number is a losing hand, and all the other numbers win. So how do we express this to a computer? Well, we cannot say that any number divisible by 3 is a losing number, because even though every third number is a losing number, this sequence begins with the number 1. But we can say that if we take the given number, subtract 1, and then see if that result is divisible by 3, that's a losing number, and all other numbers win. So looking for patterns, and especially looking for patterns by starting with the simplest case and incrementally building up to more complex cases, is a key tool in the software engineer's tool belt to help crack some really tough problems. Thank you so much for joining me, and I will see you again next week.